Hello students, how are you? Hope you are all in the pink of health. I am Atunu Roy and you are watching Bond Making and Bond Breaking channel. From today we are going to start some basic of organic chemistry. Okay. From today we are going to start some basic concept so that you can easily understand the organic chemistry without any problem. To go forward, you have to know the basic concept. What are the basic concept? So without wasting time, let's go and go through the chapter. So the first point is the Lewis structure of carbon as well as the Lewis structure of methane. Okay. So the structure of methane. So the first one is the structure of methane. That is carbon, and here H, and here H, here H, and here H. We know the valency of carbon, that is 4. Okay, so this is y-axis and it is x-axis. So it is x-axis and y-axis, and another is z-axis, which is in front of your side. Okay, and the another is back of this point. Okay, so there are the 4 valence which is denoted or which is shown to you with the help of hydrogen. Okay, so upper plane is drawn in this way. If you want, upper plane is drawn in this way and the lower plane is drawn with the dash mode. You can write through this. And the bond angle between hydrogen, carbon and hydrogen will 109 degree 28 minute. 109 degree and 28 minute. And what is it? Hybridization, that is sp3. Okay, to know the hybridization you have to remember something. What are they? That is, if the bond between carbon and carbon is single, so this is sp3 without any doubt. If the bond between carbon and carbon which is double, then it is sp2 without any doubt. And if the bond between carbon and carbon is triple, so this is sp. So let's tell with me: carbon carbon single bond sp3, carbon carbon double bond sp2, carbon carbon triple bond sp. Okay, carbon carbon single bond sp3, carbon carbon double bond sp2, carbon carbon triple bond sp. So the carbon has single bond, and this bond is between carbon and hydrogen. So this is single bond, so this is sp3. Okay, so this is sp3. As well as this bond is called sigma bond. Okay, this bond is called sigma bond. Okay, so number of sigma bond, if right here, if number of sigma bond is 4. What is the number of sigma bond? Is 4 in this compound. What is the compound? Compound is methane. If the number of sigma bond is 4, on that time this hybridization will be sp3. Okay, this is also another method. And we came to know from the chemical bonding. What is the formula to calculate the H? That is half into V plus M. What is V? V means valence electron of the central atom. What is the central atom? In that case, what is the central atom? Central atom is carbon. So what is the valency of carbon? Let's talk about the valency of carbon, that is 4. So half 4 plus. What are the numbers? of monovalent compound which is attached to the carbon, that is 4. Number of hydrogen atom 4, and hydrogen is a monovalent compound. Okay, hydrogen is a monovalent compound. So number of monovalent compounds or monobonded atoms, that is 4, and 8 divided by 2, that is equal to 4, and we know if 8 is equal to 4, that is also sp3. So there are so many ways. With that help or with those help, you can say easily that this carbon contains sp3 hybridization. Is it clear? Is it clear to you? Okay. Now hybridization. Now hybridization and shape of simple hybridization and shape. Okay, hybridization and shape of simple shapes, that is shapes, hybridization and shapes of simple organic molecules. This is our topic for today's lecture. Okay, this is the first organic lecture. From here we are going to learn something in depth. Okay, so this is for the beginner. This is lecture for the beginner. So hybridization and shape of simple organic molecules. What is the heading? Hybridization and shapes of simple organic molecules. So what are the simple organic molecules? First simple organic molecule, that is CH4. Very important compound for organic chemistry. Okay, and the next one is C2H6, and the third one is C2H4. Fourth one is C2H2. Fifth one is CHCl3, and the last one is C6H6. Okay, C6H6. So CH4, we came to know the structure. CH4, this is tetrahedral. This structure is called tetrahedral. Okay, this is tetrahedral structure. And the hybridization of carbon, that is also known to us, that is sp3. Okay, sp3, and the bond angle, that is 109 degree 28 minute. Okay, and this is CH4. We can write here CH4, that means CH3 bond H. This is a style to represent the CH4, CH3H, and the bond length between CH3 and H, and the bond length between CH3 and H, that is C and H, bond length C between H. Okay, here CH4, so bond length between C and H, the bond length between C and H, this is 1.09 angstrom. What is it? 1.09 angstrom. The bond between carbon and hydrogen. Okay, the bond between carbon and hydrogen, 1.09 angstrom. Hybridization sp3, bond angle 109 degree 28 minute. Okay, and the energy of the bond. So energy means if you want to break this bond, required energy, how much? That is the energy of the bond. This is the enthalpy of the bond. So, and it is observed that the energy approximately 105 kilocalorie per mole. Okay, kilocalorie per mole. Okay, if it is if it is 1 mole, then you require 105 kilocalorie energy. If you want to break 1 mole CH4, then you require 105 kilocalorie energy to break the bond. So those are the simple information for simple organic molecules methane. Let's talk about the second molecule, that is C2H6. Okay, C2H6 means C. Okay, C bond C H6 H and this. So those are H. Okay. So the bond between carbon-carbon, the bond between carbon-hydrogen, all are the sigma bond. The nature of the bond is sigma. Why sigma? Sigma means head to head. Okay, head to head overlap. There are two types of bond. Bond is classified into two groups: sigma bond and the pi bond. What is sigma bond? That is a head to head overlap. And what is pi bond? This is side side overlap. Side side overlap. So what is pi bond? This is side by side or side overlap. Or overlapping. Side overlap is the cause for creating pi bond, and the head to head overlapping is the cause for creating sigma bond. Okay, so the bond between carbon hydrogen and the carbon carbon is sigma bond. Okay, and the hybridization of this carbon, as the number of sigma bond is 4, so this is sp3. So this carbon is also sp3 and this is also sp3. Okay, is it clear? This is sp3 and this is sp3. Okay. Okay. And the bond angle. Bond angle, you get to know that is 109 degree 28 minutes. There is no doubt, 109 degree 28 minutes. Okay. And the required energy to break the bond, this is 100, near about 100, and the correct value is 100.61 kilocalorie per mole. Okay. So the bond, nature of bond between carbon and hydrogen and carbon carbon, that is sigma. Sigma means head to head overlap, and bond is classified into two categories, which is sigma bond and another is pi bond. Sigma bond, this is head to head overlap, and the pi bond is side side overlap. And the bond angle is 109.28 degree 28 minutes. Why? This is sp3 hybridization, and the bond energy to break bond energy, that is 100.61 kilocalorie per mole. If you have 1 mole ethane, so you need 100 kilocalorie energy to break it. Okay, this is the simple information for C2H6. Note down on your copy. Okay, note down on your copy. Next, C2H4. C2H4. Okay. So the next is C2H4. H4. C2H4. Okay. Or you can write it like dotted. C2H4. Here the bond between carbon carbon, one is sigma bond, another is pi bond. And carbon between hydrogen, sigma bond, this is sigma bond, carbon hydrogen, sigma bond, carbon hydrogen, sigma bond. Okay, clear? Clear? The bond angle, hydrogen, carbon and hydrogen means this angle of HCH and the angle of HC double bond C. HC double bond C. Both are 120 degree. Okay, both are 120 degree. But the bond length, carbon and hydrogen is 1.08 angstrom. 1.08 angstrom. Okay, and the carbon is 1.34 angstrom. Carbon is 1.34 angstrom. Okay. Bond angle between hydrogen, this is 120, and the hydrogen carbon means this angle also 120. This angle also 120, 120, 120, 120. That's it. 120. But the bond length of carbon hydrogen is 1.08. But the bond length between these two carbon is 1.34 angstrom. Okay. So here carbon hydrogen sigma bond, and the carbon has two types of bond, sigma and another is pi. Okay. And the bond energy required 171 kilocalorie per mole. So if you have 1 mole acetylene, you require 171 kilocalorie energy to break it. Okay. Sorry, ethene. If you have 1 mole ethene, not acetylene, if you have 1 mole ethene, so you require 171 kilocalorie energy. Okay. And the structure is, this is planar. Okay, this is planar. This is planar. Go. Let's go to the next. C2H2, that means C triple bond C bond H bond H. H bond C triple bond C bond H. This is acetylene. What is acetylene or ethyne? Iron means triple bond. Okay. N means single bond. N means single bond. In means double bond. Iron means triple bond. So this is iron. Ethyne, it means number of carbon 2. 1 carbon, 2 carbon. So this is ethyne. The another name or common name for ethyne is, that's it, that is acetylene. Okay, that is acetylene. And the bond angle 180. Okay, and the hybridization of the carbon atom and the hybridization of the carbon bond, carbon triple bond. We know the carbon is triple bond, so the hybridization will be sp without any dot. So this is sp hybridized carbon atom. Okay. Any doubt? And the carbon hydrogen bond length 1.06 angstrom. Okay, 1.06 angstrom, and the carbon triple bond 1.20 angstrom. 1.20 angstrom. 1.06 angstrom, and this is carbon 1.20 angstrom. Okay, required energy to break this 230 kilocalorie per mole. If you have 1 mole acetylene, and if you want to break it for the reaction, for the any purpose, so you require 230 kilocalorie energy. Okay, so this is for acetylene. This is for acetylene. For acetylene, the hybridization of carbon atom sp required energy to 30 kilocalorie per mole. This is called ethine. The compound name is acetylene. Bond angle 180 degree, and the bond length between carbon and hydrogen 1.06 angstrom, and the bond length between two carbon atoms, this is 1.20 angstrom. That's enough. That's enough information for the acetylene. Okay, and the structure, this is linear. Okay, this is linear. Note down on your copy. Note down. Okay. Okay. And the next one is CHCl3. And the next one is CHCl3. What I say? This is CHCl3. Another simple important organic molecules. And this is like this structure is like methane. Okay. CHCl3 and CL3. Okay. And as the number of carbon atom 4, this is also sp3 hybridized carbon atom. Okay, this is also sp3 hybridized carbon atom. And the bond angle between CL and the bond angle, what is say, bond angle between bond angle of CL. Okay, bond angle of this angle is 111. Okay, 111 degree. This is 111. But the bond angle between CLCH, bond angle of this angle, bond angle CLCH, this is not 111, this is 108 degree. So this is 111 degree and this is 108 degree. Okay, 111 degree and this is 108 degree. Okay, and the information of C bond H bond angle, this is 1.09 angstrom, and the bond length between C and H 1.09 angstrom, and bond length between CCl, this is 1.76 angstrom, and the required energy to break this bond, 85 kilocalorie per mole. This is the information for CHCl3. The bond angle 111 or 108, and the bond length 1.76 angstrom or 1.09 angstrom, and the required energy to break the bond or break the 1 mole CHCl3, you require 85 kilocalorie energy. Okay, and the last one is simple organic molecule. Okay, we are gathering our concept on hybridization and the shape of simple organic molecules, and the last example is C6H6, and this is familiar to us with the name benzene, or phenyl. Okay. There are 3 pi bonds. That means 6 pi electron. Okay. We know Huckel rule. If any element follow these rules, 4n plus 2 pi electron, okay, then this compound is called, if benzene follow this rule, then benzene is called aromatic compound. So let's see is the benzene aromatic compound. So number of pi bond. If we put the value 1, 2, 3, any integer number. If we put value of 1, can we get 6 pi electron? Let's see, 1 plus 2, this is 6. So 6 pi electron, yes, we get 6 pi electron. With the putting value 1, 2, 3, any one, we put the value, I put the value 1. So putting this value 1, we get 6 pi electron, and this is the number of pi electron of benzene, so it is matched. If the pi electron is matched, so the compound can call aromatic compound. So this is aromatic compound. The first characteristic, this is aromatic compound. We have to know benzene is an aromatic compound. What is aromatic compound? Aroma, this is the word which means a sweet smell, sweet perfume. Okay, and from here benzene is an aromatic compound, and it follows the Huckel rule, that is Huckel rule. What is that? That is 4n plus 2 pi electron. If it is matched the number of pi electron of that compound, then it can be called, this is aromatic compound. Okay. And the bond between hydrogen carbon bond angle between, and the carbon double bond carbon, single bond carbon double bond carbon, single bond carbon, the bond angle 120 degree. Okay. And the bond length carbon and hydrogen, the bond length between carbon and hydrogen 1.09 angstrom, this is common, 1.09, and the carbon 1.39 angstrom. Carbon double bond for carbon 1.39, for carbon hydrogen 1.09, and the hybridization of each carbon sp2, and required energy 110 kilocalorie per mole. That's enough. So this is the aromatic compound. Why is it aromatic compound? Because it follows Huckel rules. What is the rules? The rules is 4n plus 2 pi electron if it is matched to the compound containing the pi electrons. If it is matched, then we can call that compound is aromatic compound. What is aromatic compound? Which compound has sweet smell and follows the Huckel rules is called the aromatic compound. In generally, there may be exceptional. Okay. This is aromatic compound, and the bond angle for carbon, hydrogen carbon double bond carbon, single bond carbon 120, and the bond length between carbon 1.39, and the bond length between carbon and hydrogen 1.09 angstrom. And if we want to break 1 mole benzene, we require 110 kilocalorie energy. So that's enough for this lecture. Thank you for watching. Keep supporting, keep studying. Take care of your health. Goodbye.